Hello everyone. This is a quick video on how to type equations, mathematical equations in using Word, and also how to use Excel to make graphs and the way you should be making the graphs. Okay, both of these should be helpful for you to type your lab reports or other things in future courses. So let me show here. I have Microsoft Word open. This is the home page. And I have it on font 16 just um, uh, to be able to see it on the screen nicely. So if I want to type an equation, for example, I can put insert here and I click equation. And now I have options to type an equation. For example, let's say I want to type a quadratic, right? So let's say A, and then I put X, and then this thing, this symbol here to the second power, and then I hit space and it becomes ax squared. And then plus bx, and then plus c, and let's say equal to 0. And so the solution to the quadratic equation is minus b plus or minus the square root of something. So if I want to just stay in equation mode, I can just hit shift and then enter, and then it will just give me equation mode. Or I can just hit enter and go to the next line and then do insert equation and go on. So let's see what the solutions are. So you put x equals, and I know I'm going to get a fraction, so I'm going to put fraction here. Fraction, and I just want a full fraction, so stacked fraction here. And so the solution would be minus b, and then plus or minus. So here I have options for, here is plus or minus, and then the square root of something. So here is the square root. So the square root of, let's say, b squared, like this, and then space, minus 4ac. And then here over 2a, so 2a. So that's how you would write an equation. I just, let's say I will hit, so I'm done with the equation. Let's say I'm just going to click somewhere here. I'm out of the equation mode. I can just hit enter. And let's say I want to type another equation. Let's say insert here. You may have heard of Taylor expansion from Calc 2 if you finished it. So let's say the sine of x, you can put parentheses. Or you can put, if you just put like this, sine, and then you hit space, it will give you what to enter into the sine. So sine of x, and then I just go like this, sine of x equals. So the Taylor expansion that says the sine of x is equal to x minus x to the third power divided by 3 factorial. So 3 factorial like this. And then I hit space, and then it becomes a full fraction. Or I can just choose the fraction option from here. It's up to me. And then plus x to the 5th power divided by 5 factorial. 5 factorial is 120, right? 5 times 4 times 3 times 2 times 1. And then minus x to the 7th over 7 factorial, and so on. Okay? I can put equal, and I can write it in summation notation. I have here summation. Here it is. So I can choose options. I want stuff here under the sum and where it ends. So I put here this. I put n equal to 0. One way to write it, n equal to 0 to infinity. Infinity, I think it's one of the oh, here it is, infinity. Or I think you can just, if you put like this, infinity. No, I think t, like so. Yeah. So, or just go like that. So that's infinity. And so it's equal to minus 1 to the n, so that the sign will alternate. And I'm just showing you how to type it, not to reason where this formula came from and so on. But let's not worry about that for a moment. And then you have x to the, I want power here, so x to the 2n plus 1. So x to this whole thing. So if I put space, this thing will go up. If I put space, it goes up. And then, or you can do it the other way. Here is another way to do it. So if you go here the script, and you can go like that. So you have x, and then to the 2n plus 1, okay? And then I can use my right arrow just to be on the line here, and then divided by n, I'm sorry, 2n plus 1, 2n plus 1, like so, and I can hit enter, and I get that, all right? If I don't want the 2n ender here, I can go like this. Let me just go backward a little bit. Let me even delete this. I don't want this whole thing. I can use the fraction also. Here it is. Here's the fraction. So I have x to the 2n plus 1, like so, divided by 2n plus 1, like this. So now I have a really nice looking equation here. I can put, let's see here. Let me go Control Z just to go back. I will hit Shift Enter now to just get another equation. Let's say I want to integrate something, the integral, all right? Integral, I have options, right? I can use this, or double or triple integral. So I can, you see the limits here, they can be here or they can be on the bottom. It's up to me. I can use this if I want. Let's say x to the second power dx, and then I want to integrate this from 1 to, let's say 3. Let me use my arrow here just to get to the right. And I put equals to what? 1/3 of x cubed, right? And evaluated between 1 and 3. I can put, if I want to use that bar, I can go, I think, yeah, brackets here. And I can use, let's see, if I want just one-sided bracket here. Let's see. I don't see it at the moment. I can use the one where you have this one, the backslash like this. I can, on top of it, if you put shift backslash like so, you would have this bar. And then I put from here, from 1 to 3, like so, between 1 and 3. That's one way to do it. Another way would be just highlight this whole thing and put it between brackets. Put it between brackets, like, where are brackets at? This one, like this. And here I can put like when you try to put like some subscript here, if you put shift and then this one slash like this, or dash, shift dash, and you put 1, so that goes to the bottom, and then this above the 6, shift 6, you get this from 1 to 3, and so you'll have 1/3 of, let's put parentheses here, and then the x cubed, so 3 to the 3 minus 1 to the 3, and then equals what? 27 minus 1 is 28, so 28 over 3, like so. All right, so that's how you would write equations. And now, let's say I have the following relationship, y equals to x squared plus 1, all right, x squared plus 1. And I want to, and I have some data points. Let's say y equal to when x is 0, and when x is 1, and 2, and 3. So let me go to Excel here. So remember, y is equal to x squared plus 1, all right? So I'm going to put the x here and the y here. And let's say x, I have 0 and 1. And if I just shade these and just go straight down, let's say all the way here, it will just give me this. Instead of typing them individually, like going 0, 1, type like, so what if I had to go to 100? This is much more efficient. In here, y is equal to x squared plus 1. So I put equal. Where is x? X is on the column here, column A. So the first one is at A5. This cell here is A5. So equals to A5, that's x, that's the x currently, to the power 2, because I want x squared, and then plus 1. And I could hit enter. So it says 0 squared plus 1 is 1. Okay, and now I want to use the same formula to compute all of these. I don't have to type it every time. What I do is I just click on this cell once, left click, and then I go to the right until I see like a plus sign. You see it becomes a dark plus sign here, and you just go all the way down, and it gives you the answer, okay, for all of them. Now, if I want to plot this, I will just shade this, shade it. By the way, I made a similar video for Google Sheets if you don't have Microsoft Excel. So in Mac, you might have the setups or the buttons may be different, but it works the same way. So you have to find them if you have a Mac. You have to find a tutorial. Sorry, I don't have a Mac. I have just a PC. And then I go Insert. So I shaded. I go to Insert, and then it gives me options here. What kinds of charts? I want this one. So I put here, and I can do this. I get connected with just bars, or this, or this, or this, or this, or this, all kinds of options, and you can put more. But I want this. Always do this one, okay? Always use this. So I'll click on it. I just want the dots, just the data points. Now I need to label this. So let's say label it. I put the axes here, titles. On the x-axis, I have x in, let's say, I don't know, meters, all right? And y, let's say, is also in maybe meters, all right? Or meters per second, whatever. Y in meters, that's not the point at the moment. So let's say this is in meters, this is in meters. When x is 2 meters, when x is 0 meters, y is 1. When x is 1, y is 2. When x is 2, y is 5, and so on and so forth. All right, so does this make sense? Let's see, the range here is from 0 to maybe 9, and that looks like x. So x is on the x-axis indeed, and y goes from 0 and it goes all the way to about 90. And that makes sense because the data for y go from 1 to 82. So I can confirm that y is on the y-axis and x is on the x-axis. If I put y first and then x second, it will put x on the y-axis and y on the x-axis. So make sure you don't reverse the axes. If whatever goes on the x-axis is on this column first, and then whatever goes on the y-axis is here. Okay, and here I can add a chart title. So I can say y, maybe let's say it's the height versus range or something. All right, versus width or range or something like that. Anyways, so I get this. You can make this a little larger if you like, to make it, more visible to you or to somebody who's reading it. So let's say I can make it 14. That sounds good. Whatever, this is really obviously up to you, and up to, the reader, how well they can see. I can click here also. I can make those larger, right? I can make them larger. I can make this larger, right? Now, what I want to show is how to add a trend line. So if I go to one of the data points, just hover over it. Notice I don't display numbers over the data points, by the way, just this, simple data points. I can right click on the data point, and then I say add trend line. So it gives me options. Is it exponential? Do I want linear? Do I want logarithmic? Do I want a power? So it says here power is not even, it doesn't even fit the data well. Anyway, so you get options here. I know it's x squared plus 1, so it's a polynomial and it's degree 2. So it is a polynomial, and I can choose polynomial degree, all the way to 6. You see 6 fits pretty well, but I have no reason to fit 6-degree polynomial. You have to have a reason. You have to have a physical reason. In here, I know ahead of time, let's say it's something that depends on x squared, so it's a 2nd-degree polynomial. So not because something fits well, it's reasonable, you just fit it through. You have to have a physical reason or mathematical reason to whatever put here. So this is constant plus x squared, that's quadratic or 2nd-degree polynomial. So I have this. Now I want to see the equation. So I scroll down. I don't want these, don't worry about them. I don't want to set the intercept. So here, display the equation on the chart. So it displays the equation. And then I want to display the R value. The R value, how well it fits. If it's 1, it means it fits perfectly. So here, R squared is 1, so it fits perfectly. So I have this. I can just shade it and just make it a little larger also. I can change the color if I want. All right. I made it red. So if you like red, like blue, whatever. Okay, it's up to you. So I have x squared, and then plus here 6e x to the minus 1. Let me just take this thing here. I right click and I'm going to copy it. In your lab report, I don't want to see a separate Excel file. I don't want to see the Excel file or the data. The data will be in Word in a table, and then I want this to be also in the lab file. I don't want multiple files uploaded. So you will save it, copy it. I go here. Let's go to the same file here, let's say. And I will right click here, and it gives me options. What should I paste? You can paste it as a picture. You can paste it as keep source formatting and link the data. Usually I don't want to link the data, because if you do this and then you go to the Excel file and modify things, it gets modified here in the Word file. So usually I want just paste it as a picture, so that let's say you forget and you go here and you change stuff here in the data, and maybe you don't necessarily, maybe you accidentally deleted something here, it gets deleted here. But if you paste it as a picture, now it's a picture and it has nothing to do with the previous one. I can make it a little larger so it can be seen. So look at this, it says y. Let's type, we were doing equations, so let's see. So I put insert. So here is the equation. It says insert, I want equation. So it says y, I don't want it there. Let me go to the equation. Y equals to, it says x to the second power plus 6e to the minus 14x. So let me put here x, and then what's in front of x? 6e to the minus 14. That is 6 times 10 to the minus 14. 6, let me just go back to my equation here. Double click. 6 times 10 to the minus 14, right? Excel, and then space. Excel, if you put this in Excel, Excel will not understand it. It doesn't know what 6 times 10 to the minus 14. It understands 6e minus 14 means 6 times 10 to the minus 14. X, and then plus 1. So what this is saying, something times 10 to the minus 14 is a tiny number. It's 0.000000, I don't know, 13 or 14 zeros and then 6, okay? So this is essentially, it's saying it's negligible. This is basically negligible. Times x. X is a small number. It's between 0 and 9. So 9 times 6 times 10 to the minus 14, that's still a very tiny number compared to 1, compared to x squared. So essentially, what we're saying, this is basically, we can ignore the 10 to the minus 4. So it's essentially, I can put equal x squared plus 1. So it's essentially that, right? Excel doesn't know that our original formula was this. It tries to fit the data as well as it can, but it just gives you this tiny number here. But we have to tell that this is a tiny number and it's basically essentially 0. So again, for Excel, if I put, let me show you something, 6 times 10 to the minus 14, it would not know what it means. So let me just type it here. 6, and then you can put x, 10 to the minus 14. It's meaningless for Excel, so it doesn't understand. But if I put here, let's say 6e minus 14, all right? 6e minus 14, now it understands that. That is something it will understand. And if I put this one, let's say if I want equals, let's say I want to multiply this number by 2, right? Equals to, where is this number here? This is A17. Let's say A17 times 3, all right? It will tell me I don't know what that means. So let's see. See, it says I don't know. I don't understand what this number means. But let's go here. Equals A, this one is A18. So equals A18 times 3. This one it will understand, will be what? 3 times 6 is 18, so it will be like 1.8 e minus 13, right? 18 times 10 to the minus 14 is 1.8 e minus 13. So let's hit equal. So it will be 1.8 e minus 13. So it understands that. So when you're entering data, make sure if you have like something times 10 to the minus something, 10 to the whatever power is e something. So E10 means 10 to the positive 10. e minus 10 means 10 to the minus 10. All right, so this is about graphing. Always display the equation, always just data points and then fit a line through them. Never use that like line segments through the data. Okay, and I will stop here.